Good morning. I'm TYu from National University. The title of my speech is Information Aggregation in Big Data, Wisdom of Christ or Stupidity of Hertz. It is co-authored with my boss, Professor Shuheng Chen, and Dr. Connie Wang. Why we do this work? Big data are changing our lives dramatically. However, the impact of this information convenience to the society-level decision quality is still not quite clear. Some people argue that more information leads to better decision as wisdom of Christ. Some others argue that more information induces people to follow the other's choice and may lead to systematic failure, referred to as stupidity of Hertz. In this work, we use agent-based modeling to study underlying mechanism of information aggregation from individual level behavior to the society level decision. And based on this mechanism, we investigate the impact of big data to decision quality. Our work is based on Orange model. We first briefly introduced Orange model and highlighted the main result. Then we extend this model to investigate the big data effect. There are n equals 100 agents in the society. In every period, 2 new products are released, and every agent needs to choose one of them to consume. The expected value V of an item is a random number drawn from the uniform distribution from 0.25 to 0.75. And agents have no information about the value of the product. After consuming an item, the agent's actual utility is also drawn from a uniform distribution from V minus 0.25 to V plus 0.25. So the utility an agent can obtain is from 0 to 1. And the value of items is completely independent from each other and independent from the earlier period. The agents make decisions sequentially, one after another, and the order of agents is random. How can they make the choice? The first agent can only choose by Turing cone. And the later acting agents can observe the choices and experience the utility of early acting agents. So the second agent can observe what the first agents what item the first agent choose and how much utility he obtained. And the third agent can observe the first and the second one. But the number of observations is up to 6. If there are more than 6 early actors, an agent can only choose 6 from the available ones to observe. How will an agent make a choice after observing the choices and utilities of 6 other agents? Each agent manages they do this by the strategy. Each agent manages a strategy pool with 31 strategies, at least in this table. The first strategy is the highest average, means that the agent will choose the item in the 6 observations which provides the highest average utility. And the highest average 2 means choose the highest value, highest available utility item. At the same time, this item must occur at least twice in 6 observations. And another interesting strategy is majority, which by which an agent will choose the item that the majority in the observation choose. And follow last means that an agent will choose the same item as in the last observation. There is also a random strategy, which means that the agent chooses without observation, just randomly select one. Which strategy would an agent use to make choice? Each agent, they do this by a score, by assigning a score to each agent. The score, each agent is assigned a score measuring how good it is. In each period, an agent applies the strategy with the highest score to make a choice. At the end of each period, each agent updates the scores of the applied strategy. If the strategy provides a higher utility, the score will be increased. Otherwise, the score will be decreased. We should notice that each agent manages his or her own strategy pool by him or herself. Hence, different agents may assign different scores to the same strategy. This is the main result of Warren's work. The horizontal axis is the period, and the vertical axis is the success frequency, each point for each period. What's the success frequency? In each period, there are 100 agents. Some make the right choice, some make the wrong choice, and the frequency and the ratio proportion of the agents who make the right choice is the success frequency. From this figure, we can see that as the time goes on, as the agents learning in the process by the reinforcement learning, we can see that the average decision accuracy, the mean of the success frequency is increasing. However, at the same time, there are much more agents make the wrong choice. The probability that most of the people make the wrong choice in the lower right side of the figure, the probability that most of the people make the wrong choice is increasing. So the average decision accuracy is a measure of the wisdom of Christ, and the probability that most people make the wrong decision is an indicator of the stupidity of her. So we can say that both the wisdom of Christ and the stupidity of hers exist in this model. And after a long time of evolution, learning, the society will reach a quasi equilibrium, which means that the society reach a relatively stable state without any trend. We extend the model to study the effect of big data. Big data play two roles in information aggregation. The first is to increase information processing capacity of agents. Which means that the big data enable us to observe more information and processing more information. The second function is to enlarge the search scope, that is, enable the agents to access information within a broader range. First, we see the observation capacity, information processing capacity effect. The observation number, which is the indicator of the information processing capacity, is fixed as 6 in Warren's model. In order to investigate the information processing capacity enlarging effect of big data, we simulated with observation number from 6 to 30. This is the result. The horizontal axis is the observation number in both figures. The vertical axis in the left is the mean success frequency at the quasi equilibrium, the stable state. The mean of success frequency is a measure of the wisdom of Christ. We can say that at the observation number increasing, the wisdom of the Christ is increasing. The big failure frequency at the quasi equilibrium is the measure of the stupidity of hertz. It is keep decreasing. So we can see that if the internet and the big data can enable us to process more information, the wisdom of Christ can be enhanced, and the stupidity of the hertz can be diminished. However, the potential for increasing the information processing capacity is very limited because the time and the effort and the cognitive capacity of a human being is limited. Another function of big data is to enlarge the search scope of the agents. In a rate model, the agents can access information in a global scope. He can see things in all 199 other agents. In order to investigate the search scope effect of big data, we extend the model to a simple structure. We assume agents are located in a ring structure. 1 is connected to 2 connected to 3, 3 connected to 4, and to 100, 100 connected to 1. And the search scope of agents ranges from 3 to 49. An agent with search scope R can only access the information from R agent in both sides. So there are 2R number of agents he can access in total. Although they can access 2R agents, the observation number is fixed as 6. If 2R is larger than 6, the agent observes 6 of them randomly. Here's the result. The horizontal axis is the search scope. The vertical axis is the mean of success frequency. Mean of success frequency is the indicator of the wisdom of crowds. We can see that as the search scope increasing, the decision making, the wisdom of crowds is increasing first and decreasing after a threshold at about 20. How about the big failure or the stupidity of hertz? As the search scope increasing, the big failure, the probability that most people make the wrong decision is keep increasing. As a result, the society after this threshold is absolutely worse off. Here's the conclusion. By agent-based simulation, we study the impact of big data to society-level decision quality. We found that if big data can enable us to process more information, the wisdom of crowds can be enhanced and the stupidity of hertz can be decreased. However, under the condition of limited processing capacity, a moderate search scope rather than the global search scope is preferred for the decision quality. There is plenty room for future work. That's all. Thank you.